Hi, and welcome to Vincent Codes Finance. In this video, I'll show how dev containers in Visual Studio Code can help you make your analysis more replicable while making you more secure. So in this video, what I'll do is I'll first show you how to get started with dev containers. After this basic setup, I'll show you how to customize your dev container by specifying the extension that you want to be installed by default in VS Code, and also some other settings that you can set in VS Code. Next, I'll go into some more Python-specific features where we'll see how you can customize your dev container to use poetry by default. And finally, I'll show you something that I find quite useful when I do data analysis locally on my machine, but I still want to use a container, which is how to mount local directories from your local machine and make them available within your container. So what are dev containers? Well, they are containers, so lightweight virtual machine that will have everything in order to execute your code for your analysis separately from your local OS. If we look at this figure from the Visual Studio Code documentation, it kind of illustrates pretty well what's happening here. So typically, what you'll have is that you'll have your local OS with your VS Code and everything to execute your code on your machine. With containers, there is a separation. So VS Code will run on your local machine, on your local OS. So the editor and most of the extensions that are part of the UI side of VS Code. And this VS Code editor will connect to the VS Code server that runs in a container, either on your local machine or on a distant machine. It could be either. In this tutorial, I'll show you how to run them locally. So this VS Code server will take care of running all the workspace extensions, so extensions that interact with the workspace more than with the UI. And everything else related to executing your code will also take place in your container. So whether it's running your Python code, whatever you access through the terminal, everything will be contained in this container. So one benefit is that it's going to make you more secure. In the past few months, there have been multiple events in which malicious actor injected bad code into popular repositories or other repositories that had names similar to popular repositories, so that you could make a typo by installing with pip, and this would make you at risk. Whenever you use open source software, you never know where all the software is coming from unless you've actually audited everything. And as a researcher, at least for me, I don't have time to audit everything. So it's either you stay safe and try to only use really widely popular packages, which is not always convenient, or you can try to instead make your environment more robust to such attacks. And dev containers are a good way to achieve that. They're not perfect. They won't make you 100% safe. There's nothing that's going to make you 100% safe. But by isolating the runtime of your code from your local OS, from your main OS, it will make you less vulnerable to these types of attacks. But even if you're not worried about these kinds of attacks, dev containers are a great way to make it easier for your collaborators and others to run your code the way it ran on your machine. And why is that? Well, it's because when you define your container, you not only define, say, the packages that you're using, you're actually defining the OS and all the configuration for the virtual machine that will execute your code. Now, I'm not saying that containers are perfect. There are some limitations and there are some downsides. So one of the downsides is that there is overhead when you're using containers. So it might make everything a little bit slower and use more RAM on your machine. And there could also be compatibility issues. So for example, if you want to execute code that uses the GPU. So in my case, I'm on Mac, but all these containers, they are Linux based. So that means that within the container, I can't access the GPU. At least I haven't figured out how. If you know, let me know in the comments. So first, we'll need a software to build and run our container. The default option is Docker. So Docker isn't the only container runtime that is supported with dev containers, but all the documentation is based on Docker, so it makes it much easier to use Docker. So in order to install Docker, all you have to do is to go on docker.com in products, Docker desktop, and then you can download for whatever platform you're using. So that's the easiest way to get Docker installed. Be aware of the license here. There are other alternatives if you don't want to pay this, but for this tutorial, I'll stick with the default approach. Once you have Docker installed, then you can add to Visual Studio Code. One extension that is super useful to have in this context is the devcontainer extension from Microsoft. So you can just search for that and make sure you install it in your local VS Code. So once you've got the devcontainers extension installed, you'll have a little menu here that you can click, and then you'll have a different new options. So you could create a dev container from scratch, and that will only run in the Docker. That's not what we want. What we want is to add dev container configuration files. So for that, we can do that from the command panel. If you click that, you can either have it added to the workspace or to user data folder. So I will add it to the workspace so that the configuration can be shared by others. And then it will offer different options in terms of what type of container I want to create. In this case, what I want is I want to create a Python tree container. It has been suggested by GitHub Copilot. Otherwise, you'd have to go and click Show All Definition, and then you can scroll. There are some definitions that are defined for LaTeX, for Anaconda, if you would rather use that. In this case, what I want is I really want the Python tree default one, which for me, it's listed up top because Copilot has detected that that's the one I use most of the time. And then once I click on that, I can have a menu of different versions that I want to use. In this case, I'll use the 3.12 Bullseye, which is the default. So I'll have the latest version. And then we can also get a list of additional features that we want to use, that we want to add. So this would be a good time if we wanted to add poetry. Well, we'll go back to that later. I just want to do it by step. But if I was going to be doing it for me, I'd be just adding poetry via pipex right away. But that's not what we'll do just yet. Okay, so now I've got my dev container that's created. Visual Studio Code is offering me, now that it detected a dev container.json file, which is actually located in a hidden directory called .devcontainer. Okay, so now I lost my little prompt to rebuild the containers, but that's okay. I can just click here, and then I can just click on reopen in container. And when I do that, Visual Studio Code is going to use Docker to create a new dev container. So a new small lightweight virtual machine using the configuration that's defined here. And now that's what I have. Right? So if I go here and I look at the present working directory, I'm in -workspace -dev containers. That's not my local file system. So it's now running inside the dev container, and I can see it on top here. It does say that it is running inside a desktop Linux while I'm on Mac OS. And you pretty much see it everywhere. You see it here as well. Okay, so these dev container images, they are a bit dynamic in the sense that by specifying that, what it will do is create a Linux distribution with Python 3.12, but it will look at the host architecture and use the proper Linux image. So I'm on Mac, it's an ARM64 architecture, so it's using that Linux image so that it runs natively on my CPU. But if I then share this repository with one of my co-authors that is on a PC, it will actually download the proper image for this architecture. So it's not exactly setting the actual OS, but it is specifying a lot. You can actually specify the actual OS if you want, but then you are losing that cross-platform development possibility. And if I look here, I can go and then, yeah, I do have Python 3.12 working on Linux. So what's going on here? My Visual Studio Code is actually running half on my Mac OS. So that's the part that I see, the UI side of Visual Studio Code, works on macOS. And then internally it connects, and everything that is related to the code or to running something actually runs inside the virtual machine. If I create a new Python file here and I start typing port, say import pandas SPD, all the linting, all these checks by pylons, they are running inside the dev container. So anything that is code related is isolated from my main machine. But we can check the code actually should work. And yes, it does. So everything is running inside a dev container. By the way, if you find this kind of stuff useful, just hit this subscribe button. So now I'll go and I'll just commit these files so that they are in my repository. And I'll sync with GitHub. And the nice thing about this is that now if I go on GitHub in my repository, I see that now I've got a new commit here. I can actually go in the code tab here, click on Codespace. Dev containers are what powers Codespaces. So in this case, if I wanted, say I didn't have my computer, it broke down, I had to borrow a loaner or something, I can just go click here and create a Codespace. So what it's going to do now, it will build my Codespace, which is basically just a remote dev container, and then the UI runs in the browser. So that means that you don't have anything else. If you want to develop on an iPad, you can use that. I don't like it as much as having my local setup, obviously, but it is really convenient. At least for me, when I'm teaching a group of students, some can install them on their machine. This is our fail-safe, right? So it's a backup the students can revert to. They can actually access that right away. One thing that you have to watch out for if you're using Brave, sometimes having the Brave shield can cause issue, not all the time. The first time you create the container, it takes a bit of time because it has to create a new virtual machine, basically for your project. But once it's done, it's done. And then I've got everything here set up as if I was on my machine. Here I can go into Python, and now we see that we're running on Linux. It is not the same version as we had before because now it's not running on my machine anymore. It is running on GitHub servers. Right? Obviously, there is a cost associated with that. There is a kind of free tier if you're not using it much. After that, you have to pay by the hour, but it is a convenient solution if you want to either not run anything on your machine or you can't, things like that. So this is the same thing. I don't use that typically, so I'll just close it. Make sure if you've tried it to go here in your Codespaces and make sure that you manage them and that you actually shut it down, either stop it or delete it so that you're not billed for using that Codespace. Okay, so now that's good, but let's say that I want to customize a bit my container. Well, if I go here in my extensions, what I'm going to see is I'll see all the extensions that I've got installed locally. So I've got my theming, I've got a different extension, things like that that I've installed locally. Then some will be grayed out because they're not installed in the container, so the container can't access them, right? So I can just click on them and have them installed in the container, which is an easy way to do that. So for example, if I want Git graph, I can just click, it's gonna install in the container, and now it's gonna show up as being installed in my container here. One thing that you may notice is that I don't actually have Jupyter, so I won't even be able to use the interactive window. So obviously I want to install that, so I'll go here and look for Jupyter, and I will install it in the dev container. So now once it is installed, I can actually open the interactive window. It will load. It will say, well, your Python 3.12 requires the IPython kernel package. That's true. I do need that to run the interactive window. I could either install it directly, But here what I'd rather do is to use Poetry to manage all of that. So I'll wait before I install this. So that's nice, but say instead of having to install it manually, I wanted to make sure that everyone that used the dev container had the same extensions installed by default. One reason I can think of is for formatting. Say I want everyone to use rough or black for formatting, and I want to make sure that it is set to format on save automatically for everyone. I can actually specify that in the dev container file. So here, if we go to our devcontainer.json file, I can add a lot of things into customizations here. So with some editing magic, here's what I have. So how does it work? Well, I have to make sure that the JSON is properly formatted by adding the comma here. So in the customization tag, I'll customize for VS Code. So first, I'll make sure that the rough extension is installed. So this is the identifier for the rough extension. And then I'll add some settings to VS Code. So it's VS Code, then VS Code within VS Code, and then settings. And then what I'll do is I'll set the default formatter to be rough, code action on save. So that's going to be fix all and organize the imports. I want to make sure that I'll also deal with unused import, and I want to make sure that everything is set to format on save. So if I add that, I save, it's going to prompt me to rebuild in order to apply the changes, so I can do that. And after I've rebuilt my container, I can go here in my extensions and see what's installed in my dev container here. I will have rough that is installed. Now let's move on to Poetry. Okay, so say I wanted to use Poetry, because that's what I use. I could have a command where I install it every time, but there is an easier way. For that, we'll add to the containers.dev website that has different guides, but also templates and features that we can use. So the features, they were proposed to us when we first created the dev container, but here I can actually look at all the available features. So what are these features? They're just kind of add-ons that go on top of your base container that you're using. So we're using the Python 3 one, and these features will be added on top. So we can combine multiple features, and what they do is they make it easier for us to kind of install additional software. So in this case, I want Poetry, so I can look at the Poetry features that are available. There's two. There's Poetry via PipX and Poetry persistent cache. This one is actually more recent, and this is kind of the modern way to install it. So this is what I want to use. And here all I have to do is copy this into my dev container file here. I'll add the comma. Now I save. I will rebuild. And now if I go here, I'll see that Poetry is installed. So I could now just create my repository. I do have a pyproject.toml file here that's just installing Python, Pandas, and Jupyter. So I could install it manually whenever I create my dev container, or I could also set it to be installed automatically whenever I create the container. And for that, what I'll do is I'll use a post create command here. And if we look at my post create command, what is it doing? Well, it's setting Poetry to install the virtual environment inside the project, because so that it shows up here in the .venv directory. And it's then running Poetry install, and then it will activate the shell by calling Poetry shell. So once I save that, again, it's going to prompt me to rebuild and apply the changes. That's what I'm going to do. Now what I'll see is that it's actually running the commands. It installed all my dependencies and it activated the environment. So now if I go into my test.py file here, I can actually go and do import pandas as PD, and then do df is equal to pd.dataframe. I'll just take some random one and then print df. Now, if I run that, it will actually say it hasn't found my module named pandas, so it won't work. And why is that? Well, it's because when I run Python, it's actually creating a new terminal in which the environment's not activated. So make sure that I'm using the right environment. I first need to click here and then select my environment. So I'll use this one, the one in the workspace. And once I've set that, now we see the warning here disappears. And if I run it, now everything works. So now that's pretty good. The last thing I wanted to show in this video that I find quite useful when I do some analysis is to mount a local directory. This is especially useful for data, input or output data. When I'm dealing with large files, I don't want them to be copied or linked directly into a dev container. Sometimes I have them stored elsewhere on my machine in another repository, and I want it to be available directly in the container without having to copy all these files. So this is what we'll do. So in order to do that, we'll go again in our dev container file here. So now I have a directory here in my local machine. I can just go and quickly copy the path to this file, which will give me the path to the directory. So if I just copy the path here so we know what we're dealing with, this is the path to my file. So what I want is to mount this directory here and make it available into my dev container. So for that, I'll add one customization called mounts right after the features here. So this will be the entry. I just want to make sure that I get the proper directory here. And now what it's going to do is when it mounts the dev container, when it builds it, it's going to map this local directory on my machine to this target directory inside the container. So now if I save and rebuild, I should be able to go into cd mount look, my directory data is there, so I can go into cd data, and then my file is there. But if we look at the directory where I'm running, it's actually inside the container. So I've mapped these two directories. If I create a new file called file.txt, and I go back to my directory, it has been added here. That's it for this video. If you want to know more, you can look at the Visual Studio Code documentation. It's pretty thorough, or you can go on containers.dev and explore what are the available features and different templates that you've got there. If you enjoyed this video, please like, and also don't forget to subscribe if you want to get notified of my future videos.